The focus standard for this lesson comes from Grade 8 Statistics and Probability, Standard 4, Construct and Interpret a Two-Way Frequency Table for Two Categorical Data. The topic for this lesson comes from Data and Statistics Two-Way Frequency Tables, Part 1. Our essential question for this lesson is, what are the two different types of two-way frequency tables and how are they used in statistics? Please take a moment, pausing the video if you need to copy down the standard, the topic, and essential question. Be sure to include today's date, set up your question column and your note column, and resume the video when you're ready to begin. First, we need to start off with a little bit of vocabulary. We have three vocab words here: categorical data, frequency, and relative frequency. So let's start with categorical data. Categorical data is data that is classified into different types: gender, color, vehicles. So that when you ask a question, the person answering is giving you a response that fits into a category, and it isn't necessarily something you're measuring. You might count it, but you're not measuring it. So it all goes into a different bucket or category. Frequency is the number of times something occurs, so you can count it. Like how many times do you see a red car pass by the school? So that would be an example of collecting data based on the frequency that you see a vehicle of a specific color. Relative frequency is how often something happens divided by all the outcomes, and it's recorded as a ratio, a decimal, or a percentage. So if we wanted to compare how often we saw red cars to blue cars, then we would take each of those counts, the frequency of the red divided by the total number of cars, as well as the number of blue cars divided by the total number of cars. And we could do that as a ratio, which is another word as a fraction. We could divide that, turn that into a decimal, or we can multiply that decimal by 100 and turn it into a percentage. So the relative frequency is once you've done some calculations to show the ratio, the decimal, or the percentage of how often one thing happens compared to all of the outcomes you were taking into account in your data. So let's use an example of some data I got from a website called mathbits.com talking about a survey for a car. So the example problem is that a survey was conducted asking if you could have a new vehicle, would you want a sports utility vehicle, also known as an SUV, or a sports car? And here were the results. Of the 60 males surveyed, 21 want a SUV and 39 want a sports car. Of the 180 females surveyed, 135 want an SUV and 45 want a sports car. So when we set up a frequency table, we have to figure out what are our two variables. Well, there's two things here. We have males and we have the second variable. So I'm going to highlight that a different color. So we have two variables, gender and the types of car. And now we want to put this into a two-way table. So a two-way table is helpful because it's a visual way, and I'm about ready to uncover this. So a two-way frequency table is a visual representation of the possible relationships between the two variables using the raw data. So our two variables were gender and the type of car, and now we're going to set up a two-way table for that. Two-way frequency table. So it doesn't really matter where each variable goes. So here we have the gender and the type of car, and we're making the different categories for each variable. So for gender we had male and female, and for type of car we had SUV or a sports car. So we set up those rows and columns, and then we also make an extra column and an extra row for the totals. So now let's go ahead and fill in this. So how many males said they wanted an SUV? So it said 21 males want an SUV. So in this cell, that's what we call these boxes, where male and SUV, we would put in 21. Since 39 males wanted a sports car, here, where male and sports car intersect, we would put in 39. Now when we add these up, the total should be the same total number of males that were surveyed, and that was 60. And when in fact we add 39 to 21, we get 60. So this first row tells us that 21 males wanted a SUV, 39 males wanted a sports car, and 60 males in total were surveyed. Now we can do the same thing for females. 135 wanted an SUV, so we'd put 135 here. 45 wanted a sports car, we put that there. And a total, and when we add these up, we do get that total, a total of 180 females were surveyed. So we're almost done, but now we need to make sure we make our totals in our columns as well. So we want to look at, well, how many total people, regardless of their gender, how many total people wanted an SUV? So we're going to add 21 to 135. I'll give you a moment to do that. And then we wanted to know how many total people, regardless of gender, wanted a sports car. We would add that down and put that total here. And how many total people were we surveyed? So if we add 21 to 135, we're going to get 156. If we add 39 to 45, we're going to get 84. And if we add 60 to 180, we're going to get 240. Now it's important to note that this 240 should be the total from these two categories, this first variable of gender, so the total number of people and their gender, or the two different types of gender, should add up to 240, and the totals from this variable, the type of car, should add up to also be 240. If not, you need to go back and look at your data. Alright, so there's a little bit more to this two-way frequency, and there's a little bit more vocab to it. So when you're looking at individual responses to the two variables, so 21, 39, 45, and 135, those would be called individual responses. Those are individual cells. They're colored blue. What those are referred to is called joint frequency. So these are little individual joints, pieces of the data, and so we call that the joint frequency. When we're looking at the totals, and I call it orange, but I didn't have an orange highlighter, the totals for each of the categories, then those are called marginal frequency. One way to help remember that is if you think about the margins of your paper, right? That's what's on the edge, the header, or where the red line is on notebook paper. Those are the margins, and totals here are marginal frequency. Please know that 240, the overall total, is not part of the marginal frequency. It's just 60, 180, 84, and 156 in this case. Alright. So now we're going to take a look at another type of frequency table, the relative frequency table. So we're going to take the same data, but now we're going to do some calculations with it and turn it into a ratio or decimal or percent. So here in a two-way relative frequency table, it's again a visual display of the data once it's been turned into ratios represented as either fractions, decimals, or percents. And so this is what we refer to as a whole table relative frequency. So, and here in our essential question I mentioned that there's two, but this is also part one. So there's other types of relative frequency tables, but the two main types are a frequency table, a two-way frequency table, and a relative frequency table. And then within relative frequency tables, those can be subdivided. And we'll talk about that in another video. So since our grand total of people surveyed was 240, we're going to take all of these values, the joint frequency and the marginal frequencies, and we're going to divide those by 240. That was our total number, right? So we want to know the total outcome. So I'll do this first example here. If we take 21 over 240, that would be in its ratio or fraction form, and then we can divide that out and get a decimal, and it'd be 0 and 900. So I want you to pause the video here and see if you can continue. So you do 39 divided by 240, 135 divided by 240, so on and so forth. And then resume the video when you're ready to check your work with mine. Let's see how you did. So once you've gone ahead and done your calculations and you've compared each of the different joint and marginal frequencies and you divided that by 240, which was our grand total, you're going to get these ratios. And we even did that here because you want to show that 240 divided by 240 is 1 or 100%, and that it's taking into account everyone that you surveyed. So that is what we refer to as a whole table relative frequency, where we take each of the joint and marginal frequencies and divide them by our total. This concludes our video on the introduction to two-way frequency tables. Please take a moment to make sure that your notes are fully complete, that you've started doing study guide questions and a summary,